Very good morning to all of you. Myself, Professor Mirza from Nagiri Technical Campus. The subject fluid mechanics. We are studying the dynamics of fluid or fluid dynamics, and that the last part of your syllabus as per the Savitri Phule University. We are seeing the applications of Bernoulli's equation to measure flow rate and velocity of flow. So there are four types of devices, flow measuring devices, including in your syllabus, that is Venturi meter, orifice meter, and rotameter. These three are used for the measuring discharge, and this Pitot tube is used to measure the velocity of your flow. Already we have covered the equation for the discharge and equation for the velocity. The theoretical discharge is nothing but Q is equal to A1, A2 under root of 2GH divided by under root of A1 square minus A2 square. This is nothing but the theoretical discharge. And when you find out the actual discharge, we have to add the CD, that is the coefficient of discharge, the equation. And sometimes if you know the discharge, you can able to find out the coefficient of discharge. Also, we have seen the orifice meter, their construction and their working. We have seen yesterday. Also, the discharge is same as we have seen the Venturi meter, but here, due to large energy loss, the coefficient of discharge is varying from 0.59 to 0.88. In case of Venturi meter, it is 0.95 to the 0.99. And then we have seen the rotameter, directly it is doing the discharge, okay, to the flow grading, and then Pitot tube to measure the velocity of flow, and that velocity of flow is nothing but V is equal to, theoretically you can write down V is equal to under root of 2GH. Okay. And to find out the actual velocity is nothing but V actual is equal to CV into OGH. The CV is nothing but your coefficient of velocity. The CV is nothing but here, the coefficient of velocity. And also we have seen the hint for solving the problem based on Venturi meter, orifice meter, rotameter, etc. Okay. So today we will solve the example. Today we will solve the example. Okay. And we write down the example, we will solve example. Write down the problem. 30, example number 1. Or 30 centimeter by 15 centimeter. 15 centimeter Venturi meter. Venturi meter is fitted in a horizontal pipeline, carrying 10 oil of specific gravity, oil of specific gravity 0.8. The pressure at the inlet of meter is the pressure at the inlet of meter is yani it is nothing but P1 14 Newton per centimeter square and Newton per centimeter square, and and at the throat at the throat at the throat the vacuum pressure is 37 centimeter of mercury. 37 centimeter of mercury. Assume 5% of the differential head, 5% of the assuming 5% of the differential head is lost between the inlet and throat. The inlet and throat. Inlet and throat. Determine the rate of flow through the pipeline. Determine rate of flow of oil through the pipeline. Okay, so this horizontal pipeline is given. Write down first the given in the example. We'll solve this example. Example 1. In case of your Venturi meter, that is flow measuring devices, a 30 centimeter by 15 centimeter Venturi meter is fitted in a horizontal pipeline carrying a oil of specific gravity 0.8. So S0 is given 0.8. We'll write down given. So it is 0. The pressure at the inlet of meter is pressure P1 is given by 14 Newton per centimeter square. 14 Newton per at inlet of the pipe. Okay, and pipe is 30 by 15 centimeter. So the diameter of pipe D1 is 30 centimeter you write in the meter, it is 0.3 meter, and d2 is the diameter of throat. It is the diameter of throat, and it is given 15 centimeter, or you can write down 0.15 meter. This is the diameter of 5. Okay, diameter of throat, you know. Pressure also given, and pressure at the at the throat, the pressure is 37 centimeter of mercury. Here pressure P2 is given in terms of head, that is P2 upon gamma is nothing but minus 37 centimeter of mercury. Okay, and you know the specific gravity of mercury is nothing but that is 13.6. Okay, so weight in water is nothing but the specific gravity of the material. The specific gravity of oil is given, mercury is given. So if you write down P2 by gamma is nothing but minus 37 centimeter of mercury. Also, the head loss or differential head is given. Differential head is given 5%. Differential 5%, differential is lost. So 5% differential head is lost. Head is lost. This is also given an example. So here ज्वाइन हुआ तो थोड़ा इन्फॉर्म कीजिए, तो समझ में नहीं आता तो ज्वाइन हुआ तो ओके. Person I think so left after joining. There is no much left. So here you can see the P2 upon gamma is minus 37 centimeter of mercury, and that loss is 0. That is 5%. HL is given by 5%, that is 0.05. If I write down 5% in terms of value, and that is nothing but P1 upon gamma minus P2 upon gamma. That is nothing but your pressure differential pressure or difference in pressure head. So we will start the solving with the, you know, the P2 upon gamma is nothing but 37 of mercury, centimeter of mercury. Okay, so it may be, you can written as minus 0.37 meter of mercury into the specific gravity of mercury is 13.6. So it will come 13.6 into 0.37 will come minus 5.032 of water. Okay, that is difference between the head in the water and the mercury. And you know that the Oil which is flowing here is S0, specifically is nothing but zero point 0.8. So P2 upon gamma, if you write down in case of that, is minus 0.32 divided by 0.8, that is specific gravity of that is 0 minus 6.29 meter of that oil flowing through the pipe. So if I will divide this with the, that is 6.29 meter. So these are the pressure head equals you can write down. So you know that the head loss, which is 5%, that is 0.5. T1 by gamma is 14 into 10 raised to 4. If you convert into Newton per meter square, if you convert, and this rho into G. Rho, you know, is 9810 into specific gravity of that substance, that is 0 0.8 gravity of oil, okay, minus 6.29 meter. So it will be coming something 0.05 into 14 into 10 raised to 4 divided by 9810, that is rho is for the water into specific gravity of that oil is flowing is not water, 0.8, that is 17.83. 17.83. This minus minus will be plus, that is 6.29. For head loss, total head loss, we can find out 7.83 into 6.29, that is 24 point something into 0.5, that is 5%. So it is nothing but 1.206 meter. The head loss is 1.26 kilometers. Now we know the continuity equation, you know the continuity equation, that is nothing but Q1 is equal to Q2, that is A1 V1 is equal to A2 V2. So A1 is nothing but pi by 4 into V1 square into V1, thereby pi by 4 into V2 square into V2. Am I right? If you put the value, this pi by 4 will be subtracted, and D1 is 0.3 square into V1 is equal to 0.15 square into V2. If I will do the square, 0.09, and 0.15 square is 0.025. Okay. If we are right on this, V1 is 2.3, 5, so if I write down this, because this term from the both sides It will be answer. So it will be, I will write down, so it will be 0.09 V1 is equal to 0.15 square, 0.0225 V2. If I write down in terms of V1, so that is 0.0225 upon 0.09 V2, and if I divide that, 2.0 is coming 0.25 of V2. Okay, so are you understanding this example? All the students are requested they should join on time, because once the lecture is on, then I am not able to understand who is joining. Okay, so better that you join on the time. So this one is the in terms of V1, the velocity V1 is 0.25 times of V2, or you can write as 1 by 4 of V2. Okay, now using the Bernoulli equation, using the Bernoulli equation, you know that T1 upon gamma plus T1 square upon 2G plus Z1 is equal to T2 upon gamma plus V2 square by 2G plus Z2, and a head loss. Okay. Now, if you see here, because since this is horizontal, okay, since since the horizontal centimeter placed in pipe, or you can say the horizontal pipe. So Z1 is equal to Z2, because of both they were same. So we will not consider them. If you write down, then it will be the modified equation, that is P1 by gamma plus V1 square by 2B is equal to P2 upon gamma plus V2 square by 2B plus head loss. Now you put the value. P1 upon gamma is invert 14 times to 4 divided by 0.8 into 9810, 9810 is the row, plus V1 is nothing but 0.25 times of V2. So here I will write down 0.25 times of V2 square, whole square, 2 into G, 2 into 9.81. The Kelvin acceleration. And P2 upon gamma is minus 6.29 plus V2 square by 2G, 2 into 9.81 plus head loss we have calculated earlier 1.0206. Now solving this, you have to find out V2. So V2 you will get after solving, that is 20.79 meter per second. the rate of flow, you can find out rate of flow of oil through the pipeline, through the pipeline. It's nothing but Q is equal to A1 into V1, and know that A1 is equal to pi by 4 into 0.3 square. So if you solve this, 0.3 square into root of pi divided by 4, it is coming 0.070 is area. And V1, you know that 0.25 times of V2. V2 is 20.79. So if I will 20.79 divided by 4, it is 5.1975 meter per second, meter square. Okay. So 20.79 into 0.25 अगर आप करेंगे तो it will be 5.195. So now you can find out the velocity or rate of flow. Rate of flow is nothing but discharge. Rate of flow is nothing but discharge of flow. Discharge. And discharge you are measuring into meter cube per second. So this is velocity is given by this area is 0.070 meter square into velocity 5.1975 meter per second. Your discharge will be 3.675 meter cube. This meter into meter cube per second. So this you can find out. Or discharge you can also find out that Q is equal to A2 into V2. The value will be same, it will come 3.675 meter cube per second. Both value you can put. Any of that, it will give the same discharge. So this is the Venturi problem, how to solve. But you have to understand the because the specific gravity of the flowing fluid and the manometric fluid are different, then you have to take into the consideration at each time, okay, when you are doing the calculation. And for that, yesterday the hint is given to you. Yesterday hint is given to you, okay. So here, write down. We will solve the example number 2 on the measuring device. Write down an orifice meter of orifice diameter is 10 centimeter is inserted in pipe of 20 centimeter diameter. The pressure gauge fitted on upstream or before orifice, you can say before orifice in the direction of flow are fitted on upstream upstream and downstream. Downstream is after the, yes, your orifice. P1 is given. So P1 and P2 you can say that is given 20 Newton per centimeter square and 10 Newton per centimeter square respectively. Respectively. The coefficient of discharge PD is given 0.6. Find the rate of flow or, or discharge in case of your orifice meter. Okay, so you have to find out the rate of flow discharge. So here first, before going for solution, you will write down the given in the example. So here the diameter D1, that is diameter of pipe diameter, it is given 20 centimeter. If you convert in meter, there is 0.2 meter. Here D2 is also given, that is orifice diameter, that is 10 centimeter, or I will write down 0.1 meter. And the pressure P1, it is given 20 into 10 Newton per centimeter square. We convert into meter, so 20 into 10 raised to, this minus 4 will come out, it will be the 4 Newton per meter square. Similarly, P2 if you write down, it is 10 Newton per centimeter square, so 10 into 10 raised to 4 Newton per meter square. All the things we are converting into meter. Now we know all the term, you know the diameter, you can easily find out the area. A1 is equal to pi by 4 into 0.2 square. Okay, so 0.2 square is shift of 5 divided by 4. It is 0.0314. 0.0314 meter square. Area of the orifice or diameter D2 is given 10 centimeter in 0.1 meter. If I write out 0.1 square into 5 divided by 4, it is 0.075. 0.075 meter square. Now use the continuity equation. Use continuity equation of flow, that is A1 V1 is equal to A2 V2. A1 is pi by 4 into 0.2 square V1. A2 is pi by 4 0.1 square V2. So this pi will be cancelled. Pi will be cancelled. So it will be 0.2 square with 0.04. So 0.04 V1 is equal to 0.001 V2, so V1 is equal to 0.001 here by 0.004. Again it is V1 is 0.25 times of V2. Okay, 0.2 square something is 0.04 and 0.01. That is V2 is 0.25 times of V2. V1 is 0.25 times of V2. So if I will write down by using the Bernoulli's equation again. The Bernoulli's equation again. Here the pipe is horizontal. The pipe is horizontal. Therefore, Z1 is equal to Z2. So using Bernoulli's equation, we modify the Bernoulli's equation. We can write down this. Now the term Z1, Z2 will not be there. It means that P1 upon gamma plus V1 square by 2G is equal to P2 upon gamma plus P2 square by 2G. Z1, Z2 term will not come. There is no head loss given, so that term, actual term will not be there. So if I write down P1 is 20 into 10 raised to 4 into the fluid type is not given, so we'll consider water. So it is 9810. V1 square is nothing but 0.25 times of V2. I will turn whole square upon 2 into 9.81 is equal to P2 is 10 into 10 raised to 4 divided by 9810 plus V2 square upon 2 into 9.81. After solving this, we can write down it will come 20.387 plus 3.185 into 10 raised to minus 3 V2 square plus 10.194 plus 0.051 V2 square. So we'll take all that on one side. So you can find out V2 is equal to, after solving it is coming 14.6 meter per second. Now here you know that again the velocity we know. We can easily find out the velocity discharge. You know the discharge is same by using continuities. The K1 is equal to A1 V1 or A2 V2. So I will take the discharge Q is equal to A2 V2. V2 we know, so A2 is nothing but 0.1 square into pi by 4. A2 will be 0.00785 is already calculated above. So to put the value only 0.0785 into V2 is 14.6. So it will be by solve 0.0785 into 14.6. The discharge will be critical discharge. Critical discharge will be Q acute theoretical 0.11461 meter cube per second. To find the actual discharge, nothing but CD of Q theoretical. So CD is given in the equation, that is CD is given 0.6 into 0.11461. So actual discharge will be 0.06876, 0.0687 meter cube per second. So this is nothing but discharge by using uh, your orifice method. Okay. Now you can solve the example number 3. Find the speed of submarine. स्पीड ऑफ सबमरीन, सबमरीन किसको बोलते हैं मालूम है? सबमरीन, हाँ, जो नेवी के पास अंडर वाटर their security over borders in the sea. They are called as submarine, usually used by the Navy, naval force of India or any other country. So submarine, so you have to find out the speed of submarine moving in seawater for deflection of 4 centimeter in mercury. In a mercury differential manometer. Which is connected to Pitot static tube, which is connected to Pitot static tube. Take coefficient of velocity. Coefficient of velocity is equal to 1, and specific gravity of seawater which is given by 1.03. So here, simple example based on the hint given to you. The deflection is 4 centimeter. If you write on the meter, 0.04 meter. Okay. CV, it is given 1. Specific gravity of seawater is where the fluid is flowing, and the specific gravity of your mercury is 13.6, that is mercury manometer. or manometric fluid specific area. So to solve this, so SO is 1.03, SM is 13.6. So here SM is greater than SO. So using, you can see the hint given before our this hint. So this SM is greater than SO. So we have to find out H using this formula. So H is equal to, using H is equal to X into SM divided by SO minus 1. Okay. So we know the X value is 0.04 meter, 13.6, SO is 1.03 minus 1. So we have to find out that H is, we can calculate 13.6 divided by 1.03, which is 12.20 minus 1, 12.20 into 0.04 is 0.488. 0.488 meters. Now velocity, you know the Pitot tube velocity is given by velocity, actual velocity is given by V actual is given by CV into V theoretical. And V theoretical, the CV value is given 1, V theoretical is nothing but under root of 2GH. So under root of 2 into 9.81 into H is 0.488. You can find out the velocity. Because CV is 1, no need of writing that, into 9.81 into 2 into 4.488 is coming under root of 9.577, under root of 9.577 is 3.09 meter per second. The speed of submarine is, the speed of submarine is, the speed of submarine is 3.09 meter per second. I think so you understand these examples. Very simple. The formula, you have to use the continuity equation. You know the continuity equation, that is Q1 is equal to Q2, that is A1 B1, A2 B2. Okay, that is area of cross section at 1, velocity at 1, area of cross section at 2, velocity at 2. And you know the discharge formula, that is nothing but CD into A1 A2 under root of 2GH divided by under root of A1 square minus A2 square. Is discharge formula. And you know the velocity formula also, velocity actual you also know, that is C into under root of 2GH. Okay, so based on this formula, if the discharge you have to find out, you can use that. If you have to find out the velocity, you can. And velocity also you can find out using the continuity equation. You have to find out velocity. Velocity can be calculated by using this. Right? And every time to find out the velocity, find out velocity by knowing pressure head and potential head. So we can use Bernoulli's equation. And you know the Bernoulli's equation? P1 upon gamma plus V1 square upon 2V plus Z1 is equal to P2 upon gamma plus V2 square by 2V plus Z2. If head loss is there, then there is HL also. So by using these formulas, you can easily calculate the given example. You can calculate the discharge of or flow rate. You can calculate the velocity as per. Okay. But you should remember that the hint given in the previous class is very important because the specific gravity of fluid flowing and specific gravity of magnetic flow is also very important. So you have another class, so we will stop here. So thank you for joining. Okay. From next week onward, we will